Okay, we'll start in a bit. Let us wait for uh, students to join. So, in today's lecture, we'll discuss about metrics norms, different kind of metrics norm that arise in numerical analysis, which builds the foundation to certain numerical assignments and problems, and we'll see certainly many prospects and applications of those metrics norms. So, we'll start in a bit. Yeah. So, let us start. We'll discuss. So this is numerical analysis, and we will discuss metrics norms and some results. Yeah. So what is a metrics norm? So even to before beginning that, even to even start talking of or making sense out of metrics norm, let us start discussing what is a norm. So norm is a generalization of distance in real life. And how do we measure distance? So given, just a minute, there is some issue. Okay. So am I audible? Okay. So in today's lecture, let us discuss about metrics norm, as some of you suggested in mails and last lecture. So we will see. So do you know what is a norm? And of course, after this, we'll discuss some questions on this topic related to assignments. But what do you know about norm? What can you say? What is a norm? Do you know what a norm is? Am I audible? Okay. So my question to you is, what is a norm? Do you know how do we define a norm, or what does actually, if we say something is a norm, what do we mean exactly? If no, then just say no. Okay. Yes. Yes. So the general, yeah, that is in vague sense very correct. But because we are learning math, so it has to be explicitly defined, right? But in one way, you are correct. Norm is a pseudonym for distance. It is a generalization of notion of distance. For example, if I start with, if I start with two real numbers, let's say alpha and beta, we know that the distance between them is, what is the distance? Can anyone tell? Okay. Yeah. Yeah. What is the matter today? You people are not speaking. Yeah. It will be mod of alpha minus beta. Correct. So given that, this is a number line, let us say, and assume that your alpha is here, somewhere here, and your beta is somewhere here. So alpha minus beta is basically this length, right? Mod alpha minus beta. So similarly, for a norm, we have a norm is a generalization of a norm is a generalization of distance in R. Now, when we are saying it as a generalization of distance, in what spaces we are trying to generalize? For example, if I ask you, you all have learned coordinate geometry, right? You must have learned coordinate geometry, and uh, if I ask you, let's say, the distance between x1 y1 and x2 y2. So, can anyone tell me the distance between them? Yes, so it will be x2, okay, or maybe because it is square, so it doesn't matter whether you write x1 minus x2 or y1 x2 minus x1 and square root to the this. Yeah, that is true. Now, if I want to generalize this distance notion, I will ask you for, one by one, what property do we want it to follow? Okay, let us discuss some properties of distance in R. First of all, if d is the distance function, if I define this function, so what should be the domain? You are defining, let's say, d of alpha comma beta to be mod alpha minus beta, right? We define this distance, so we need two real numbers, which means the domain should be r cross r, am I right? And the range should be, can anyone tell me the range? Okay, so if I don't know, it's very disheartening to see if no one replies. So then maybe I will continue on my own. Okay, that works better for both of us. So this range should be 0 to infinity, where this alpha comma beta belongs to R, and it has the following properties. Okay, if I ask you what is the most natural property, the first thing is it has to be non-negative, right? But this is covered here already because the range is 0 to infinity. So that part is covered. Now, first property other than that is, what should be the distance between alpha comma alpha? It should be 0, right? And I can also say that, distance between alpha comma beta is 0 if and only if and only if alpha is same as beta. Yes. Then second property is, uh, what is the other natural property that you can observe out of this? Can I say distance of, mm, there are so many properties that you can check. Distance of alpha beta is same as distance of beta alpha, right? Correct. Yes. Yes. Now if, yes, yes, yeah. So what is the problem? If alpha is beta, then it is also in r cross r, right? Any point of this form is also in r cross r, am I correct? And this map d, the map d induces another map. The map d induces another map, which is called length map. Do you know length of a vector? We denote it by this function, and this is a function from 0 to infinity, r to r to 0 to infinity, given by, in this case, it is just distance of alpha from 0. Do you get my point? So this is the distance of alpha from 0. And yes, and it satisfies certain properties. Number 1, this norm alpha is always greater than equal to 0, am I correct? Yes, very good. Second, what can you say about when norm alpha is 0? Can I say norm alpha is 0 if and only if, what happens? Alpha is 0, am I correct? Because what is norm alpha here? Norm alpha is nothing but modulus of alpha. Now, modulus of a number is 0 if and only if the number itself is 0. Am I correct? Yes. Third is, now what can you say about norm of C alpha, where C is any scalar? C belongs to some real number. What can you say about norm C alpha? Can I say that this is same as mod C times norm alpha? Can I say this? Mod C you can take out basically. And fourth, can I say norm alpha plus beta is less than norm alpha plus norm beta? And this is called triangle inequality. All of us know this. Why is it called triangle inequality? Does anyone know? Does anyone know why is it called triangle inequality? Yeah, the sum of, if you take, if you take this to be your axis, real axis, and let's say this is your alpha, just for simple example, and this is your beta here. Mm, so the distance between them, norm alpha plus beta, you know how to compute norm alpha plus beta? Okay, let me ask you this way. If this is your alpha and this is your beta, then you join it and you complete this parallelogram, right? And this quantity here, this will be your alpha plus beta. Am I correct? And you form this triangle. Let's say this is O, this is point P, and this is point Q, let's say. Now, what is length of? We know length of mm, OQ should be greater than equal to, should be less than equal to length of OP plus length of PQ, correct? Because the sum of two sides of triangle is always bigger than the length of the third side. But what is length of OQ? Length of OQ is your vector alpha plus beta, so its length will be modulus of alpha plus beta less than equal to length of OP will be mod alpha, and length of PQ will be mod beta. So this is why this is called triangle inequality, because the geometric picture is represented by this summation formula in the triangle. Okay. Now the question is, so the question is, can we define a notion of distance? So you please listen to this carefully, because based on this we will solve some problems on norms. Okay. uh, yeah, notion of distance of elements in Rn. So whatever we have for the distance in the real line, can we replicate it and construct a well defined notion of distance for the elements in Rn? That is the question. And the answer, as you know, you must know the answer should be yes, because there is a notion, and this is called norm or vector norm to be very precise, slash length map in Rn. And the all the property that we have reserved here, it should be, all these properties will be reserved. Here we did it for R, and here we will have for Rn. Yeah. So let me just change a bit. A map, any map, this it is said to be a vector norm if it satisfies the following. Yeah. So this one can do, where this holds for every alpha comma beta in Rn. So if someone asks you what is a norm, so norm is a map, okay? Is it clear? What is a norm? See, whatever analysis you will do from now onwards, if there is a certain notion of distance or certain notion of metric or certain notion of vector norm or operator norm, all these things will be a function. Okay, up until now you must have observed in mathematics that whatever notion we define it via function. So some notion will always turn out to be a function on a given space with certain properties. Okay, for example, if I ask you, you all must have learned group theory a little bit, correct? Group theory you have not seen, okay. Mm, okay, then I will not give this example, but vector norm is a map on Rn. In your course we'll stay to Rn. So basically, when we say, there is a norm on Rn, we say there is a notion of distance between two elements in Rn. But how do the elements of Rn look like? They are of n tuple, right? X1, X2, Xn. Am I correct? For example, okay, let me just clear with these examples. Let us discuss some example and then it will be clear. So number one is Euclidean norm, or it is also called L2 norm. So any element in Rn must be of this form. Am I correct? Yeah. So then we define this to be just mod x1 square mod x2 square plus mod xn square, then square root of everything, like, yeah. Now can you check that this defines a norm quickly? So you have to verify these four properties. Does the first property hold? First property hold, right? Why? Yes. Because it is a sum of positive numbers, right? Basically, it is a sum of non-negative number, and then we are taking square root. So first of all, sum of non-negative number is again non-negative, and if you're taking the square root, then it is always going to be non-negative. Now, what about the second property? Why? Because if a square plus b square is zero, right? If a square plus b square is zero, what can you say about, if a square plus b square is zero, what can you say about a and b? Both are non-negative. Yes. Yes. Very good. What about third? Third also is fine. To everyone, third is fine. Atul, Bishwajyoti, I received your emails. And yeah. Okay. So third is also fine. What about fourth? So let me write. It suffices to show triangle inequality because all other properties follow trivially. It suffices to show the. Can you prove triangle inequality? If I give you some time, can you prove triangle inequality? What about the other two? You have to prove that the norm of x plus y, this 2 in the subscript here indicates we are taking L2 norm. Okay. So this has to be less than L2 norm of x plus L2 norm of y for every x of the form x1, x2, xn, and y equal to y1, y2, yn. Yeah. Can you show this? Vishwajyoti, can you prove this? He seems not to be here. He must have just joined. Oh, okay. He's here. Yes, you are trying to speak something? No, no, sir. You cannot sell this. Similar way it can be done. Maybe take some time and prove it. Okay, all of you try to prove it, then we will discuss. I give you some, at least think of an idea, okay? Let me put you some hint, okay? Hint is, see, all these basic things should be known concretely, okay? You want to show that something is less than something, and because we are dealing with non-negative numbers, so I can show that their square, it this will happen if and only if their square is non-negative, right? Can I say this? Sorry, square both sides, correct? This will holds if and only if on squaring this will happen. Am I correct? Now, what is the square? Tell me, what will be the square? This is x plus y. The left hand side. What is the left hand side? What is the left hand side? Can you compute left hand side? What will be x plus y? It will be x1 plus y1, comma x2 plus y2, then xn plus yn. Am I correct? And what will be its L2 norm? Square of L2 norm will be mod x1 plus y1 square plus instead of mod also we can just take square, it doesn't matter, x1 plus y1 square, then x2 plus y2 square, then xn plus yn square. Now please tell me what to do now. Can you open it? Can I write it as x1 square plus y1 square plus 2 x1 y1? This is the first term, and you keep on doing this, and in the end you will get xn square plus yn square plus 2 x and yn. Am I correct? So if I collect all x1 term, so then one thing I will get summation xi square I going from 1 to n. Then I will collect yi term, I will get summation yi square I going from 1 to n. And then I will be getting 2 times summation xi yi I going from 1 to n. Am I correct? Now what is summation xi square? This is nothing but L2 norm of x. And what is this? This is L2 norm of y, and this is some non-negative term. This is some 2 times xi yi, right? Yeah. So this is norm xi. Yeah. So this is the square of this. Now we need to show that. Please mute your mic. We need to show that norm xi, square is less than equal to norm L2 norm of x plus L2 norm of y ka whole square. And by the above calculation, we know this will hold if and only if I am just substituting the value of L2 norm of x plus y square. This will hold if and only if this thing on the left hand side is less than equal to. Now, open the square on the right hand side. Tell me what will you get. Quickly tell me what will you get. What is a plus b square? This is your a, this is your b. What is a plus b square? Yeah, so just tell me in the term of x and y. So it will be L2 norm of x square, right? And then L2 norm of y square, and then 2 times L2 norm of x times L2 norm of y. Correct? Now I can say that this will hold, see, this will cancel out and this will also cancel out. Correct? You see, this is same as this, and this is same as, oh, this is so dark. This is same as this. So if I show that 2 times summation xi yi, I going from 1 to n is less than equal to 2 times summation L2 norm of x times L2 norm of y. Then this is true, right? This is if and only if. Am I correct? Now, can I cancel to both side? Yeah, so I will get, this will hold if and only if x1 y1 plus xn yn is less than equal to L2 norm of x and L2 norm of y. So I reach to a step where I have to prove this. Okay, or maybe again I can do square, after. So this will be true if and only if this square. So this will become L2 norm of x square and L2 norm of y square. Now can you prove this? Or maybe let us simplify further. This will hold if and only if. See, note that at any stage I am not losing my if and only if condition. Okay, this will be less than equal to x1 square xn square times y1 square plus y2 square. Now can you prove this? Can you prove this? Okay, you take, okay, you do it for n equal to 1 first. Okay, first you tell me what happens for n equal to 1. For n equal to 1, left hand side is this thing and right hand side is x1 square y1 square. So in fact it is equal, right? For n equal to 1. Yeah, for n equal to 2, how will you prove this? Yeah, you do it for n equal to 2. Basically you have to show that x1 y1 plus x2 y2 whole square is less than equal to x1 square plus x2 square times y1 square plus y2 square. Yeah, I give you some, you take 5 minutes and prove this. This is not difficult. You take 5 minutes and prove this. Are you done? So have you proved this? Okay. Yeah. So were you able to prove for the at least n equal to 2 case? Right hand side is greater. That is what you have to prove. But have you been able to prove? Okay, you just see the screen. Can you see the screen? Yeah. So what will be here? You see what will be x1 y1 plus x2 y2 square. Okay. Okay. Yeah. Okay. If you agree, then I can. I don't need to write this again. Yeah. And what about RHS? RHS, you will have something of this form. Some more term, exactly. And then, okay, you figure it out. It is a good exercise to see whether or not this will be less than equal to. Okay, is it fine? And then you try to generalize it. What happens in n equal to 2 case? From this, you may want to see what happens for the general case n equal to 3, n equal to 4, 5, and in general for some any arbitrarily chosen n in the natural number. Now the another norm is the maximum norm, which is known as the L infinity norm, and we denote it by norm subscript infinity. Now infinity, just to make sure that we know what norm is it. So infinity norm is nothing but you start with any element x equal to x1, x2, xn, and you take the maximum of the modulus. Is it clear? Now if I ask you, let's say we are in R3, what will be the modulus infinity norm of what will be the infinity norm of, I'm asking this, what will be the infinity norm of x, where x is, let's say, minus 1, 4 and minus 10? What will be the infinity norm? Yes, we are in R3. Yes, of course, because it has three components. So we are in R3. No, infinity norm I'm asking. What is infinity norm? Infinity norm is, so what is the maximum of these three number? Not these three number. The maximum modulus of these. So what is this? 10. Exactly. 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 Yeah. So this is clear. Now again I'm giving you some 3 minutes to see why this should be a norm. Can you tell me why this should be a norm? What is the first property? The first property is that it should be non-negative, right? Because we are taking modulus maximum of the modulus, right? So each modulus gives a non-negative term, and you're choosing maximum, so it has to be non-negative. Am I correct? Now, what about the second property? Why? Because if maximum is zero, then all of these has to be zero. Am I correct? And if the modulus of x1 is 0, modulus of x2 is 0, modulus of x3 is 0, it means x1, x2, x3, all of them has to be 0. Am I correct? And okay, now I give you some third point. I want to ask you how will you prove the third point? If you multiply it with some x, right, where x is in Rn and c is in R, what will be its infinity norm? It will be maximum of modulus of cx1, right? Modulus of cx2, because cx will be what? Cx1 comma cx2 blah blah blah. Am I correct? Yeah. Now you just go with c of xn. This you can write it as maximum of modulus of c times modulus of x1, modulus of c times modulus of x2, dot dot blah blah blah, modulus of c times modulus of xn. Can I take modulus of c common, right? Because it is independent. This is common in all, right? So this will be modulus c times maximum of modulus of x1, modulus of x2, and so on. What we are left with is this. Am I correct? Now, can you prove the triangle inequality? What do you have to prove? X plus y, the infinity norm of this should be less than equal to infinity norm of x plus infinity norm of y. Can you prove this? Do you have your copy and pen, all of you? Do you sit with the. So okay, take your time and prove it. Okay, just take 2 or 3 minutes, prove it. Is it doable? So you were able to prove it? Okay, okay. Take your time. No hurry. Take your time. Don't worry. Take your time and then do it. Just tell me when you're done. Okay. I'm here only. Take your time and do. You're saying they are equal. No, there can be cases where they are not equal. Okay, you see what will be the left hand side. Can you tell me what will be the left hand side? It will be the maximum of mod x1 plus y1, mod x2 plus y2, and mod xn plus yn. Am I correct? Yeah. Now you see, you take any, take any j, take any j between 1 to n. What can you say about xj plus yj? Or if this is confusing, then do it like this: mod x1 plus y1. Can you say that this will be less than mod x1 plus mod y1? Can I say this? This is triangle inequality, right? In one variable. Now what can I say? Mod x1 will be less than infinity norm of x. Can I say this? Because by definition, what is infinity norm of x? It is maximum of all those xj, right? So it has to be greater than equal to mod x1. Now I can do this for everyone, right? I can say that this will be less than equal to mod x2 plus mod y2 less than equal to infinity norm of x plus infinity norm of y. Can I say this? And then in the last also I can do this. So basically, everything here is less than equal to infinity norm of x and plus infinity norm of y. So their maximum will also be less than equal to this. Am I correct? You see, maximum of finite number, it will be attained at some point, right? If you're taking finitely many number, then its maximum will be somewhere here. Out of this only you will get the maximum. Am I correct? So let us say it is some xj plus yj. I don't care. Some xj yj. Some j between 1 to n. Am I correct? And we know we have just proved that this will be less than equal to infinity norm of x plus infinity norm of y. Are we done here? So the triangle inequality is true. Am I correct? Yeah. Okay. Good. Now because I am going to give you another norm and you have to prove everything for it. And this is called the L1 norm. Can you see L1 norm on your screen? Example 3. Yeah. So try to prove everything for it. Take your time and try to prove everything for it. You just write down the L1 norm, the definition of L1 norm. So what is it? You take modulus of every component and you add them up. Okay. Is the norm definition clear? The L1 norm. Now you prove these four properties. one by one. Okay. First is obvious. Second is also obvious. What about third?
Yeah. Try to prove fourth. Okay. Write down each and every step. It should be clear, even if it is clear to you. But then try to write down each and every step. Okay. Take 2 or 3 minutes. Yeah. Mute your mic, please.
Is it done? So are you done? Okay. What about the others? Maybe give them some 1 more minute or so, then we'll proceed further. Okay, so if you're done with this, then let us move to the matrix norm. Okay, now, okay, let us do some questions. As it was mentioned in the mails that you want to do some questions. So, can you prove this inequality? Let us try to prove this inequality. Can you see the inequality on screen? Yeah. Try to prove it. These are the definitions. For example, one way is very obvious. Am I correct? You just, what is the infinity norm of x? It is the maximum of the modulus of x1, modulus of x2, and modulus of xn. And let us say it will be attained at some point k, because it is a maximum of finite number. So we'll be able to catch this maximum. Let us say this is modulus of xk. Now on the right hand side you have the L2 norm of x. So what will be the L2 norm of x square? It will be modulus of x1 square plus modulus of x2 square dot 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 modulus of xn square. Now you see, can I say that this will be greater than equal to modulus of xk square? Am I correct? Because you see modulus of x1 xk square is one term, but in the sum there are n minus 1 more terms. Am I correct? Yeah. And what is modulus of xk square? It is nothing but square of the infinity norm of x. Now you cancel out the square and you will get that infinity norm of x is actually less than equal to infinity norm of t. Now you try the another side inequality. One side I have proved, you try to prove the other equality, that L2 norm of x is less than equal to square root of n times infinity norm of x. You please try to prove that. This is an important inequality. I will tell you why. So are you proving it? Is the question clear? Okay, go ahead. So, how is it going? Uh, Ajay, Atul, oh, you're trying? Yeah, go ahead. Yes, yes. So this is what you proved, right? The way I have written here, and then it just follows easily, right? All of you agree? Okay. Then try to prove this inequality. Can you see the inequality? Yeah. Try to prove this inequality. Huh? Sorry? Same way you can prove exactly. Yes. Very good. So one thing is easy, right? If you start with L1 norm of x, because again the same thing, the infinity norm of x will be attained at some point, right? So infinity norm has to be less than the sum of mod x1, x mod x2, and xn. Am I correct? Now what about the other side? L1 norm of x. Yeah. So you must have applied the same trick. Am I correct? So what you have proved is this. These two inequalities. All of you can see this. Now can from these two inequalities can you derive some relation between L1 norm and L2 norm? Do you get my point? So first inequality gives you a relation between infinity norm and L2 norm. Am I correct? The first inequality gives you a relation between infinity norm and L2 norm. And the second inequality gives you a relation between the infinity norm and L1 norm. Now, my question to you is, can we use both these inequalities to derive a relation between L1 norm and L2 norm? Can I do that? So please tell me the inequality. Take your time and do it. L2 norm is less than equal to, and what about the other way? See, you have two. See, Okay, let me start with this. You see inequality 1. Okay, you know L2 norm and L infinity norm are two different norm. Am I correct? But what does one say? One say that you can estimate an L2 norm by L infinity norm. If you have computed L infinity norm, then L2 norm you have some upper bound and lower bound. Am I correct? And same goes for L infinity norm also. If you have computed L2 norm, you have proved here that L infinity norm is less than equal to L2 norm is less than equal to root n times L infinity norm. Now you again apply this inequality, then you can say that this is less than equal to root n times L2 norm. Am I correct? So what does this say? The first part says if you have computed L infinity norm, then you have some estimate upper bound and lower bound on L2 norm. But if you consider this part, it says if you have computed L2 norm, if you have computed L2 norm, then you know some upper bound and lower bound on L2 norm or L infinity norm. Am I correct? Do you get what I'm trying to say here? If no, please say yes or no. Like something, some sort of reaction you have to give. Otherwise, how would I know? So, what does it say? Once you have computed L2 norm, you can stay closer to L infinity norm. And if you have computed L infinity norm, then also it's fine. Then you can estimate L2 norm. Now, why do we learn this inequality? Because sometimes it is harder to compute another norm than one norm. For example, which one of these two you think is easier to compute, L2 norm or L infinity norm? L infinity is easier to compute, right? Yes. So this inequality tells you now think like a computer, okay? Because we are learning numerical analysis, and in your lectures you must be seeing all those computations and all. But here the target is to, as discussed by the professor, is to make you conceptually strong. Okay, this is why we learn all these behind the scenes thing. Now, once you have L infinity norm, you can actually work with L2 norm also via this inequality. Am I correct? Yes, exactly. There will be some error. Of course, there will be some error, but for a bigger number, the error can be adjusted, right? So these inequalities helps you in computing all sorts of things out of two. For example, here the two things are L infinity norm and L2 norm. Now we know L2 norm can be a bit complicated and it is expensive. It is more expensive for a computer to compute L2 norm. Then what we can do, we can ask it to compute L infinity norm, and via this inequality we know L2 norm will be in upper bound and lower bound. So it helps us a lot. Similar thing goes for the other inequality also. For example, equality number 2. It also says the same, right? That once you have computed L infinity norm, you know something about L1 norm, and once you have computed L1 norm, you have some information about L infinity norm. Am I correct? Now my question to you is, can you give me, so using this, can I prove this inequality number 3? It is easy to see, right? See, first point, you see the first point, L2 norm by first inequality is less than equal to root n times L infinity norm. And yeah, it is clear, right? So again, you have some relation between L2 norm and L1 norm. So these, so whenever you have a lower bound and upper bound of two norms. These two norms are called equivalent norms. What do we call it? Equivalent norm. When are two things equivalent? When they're almost same, or using one we can compute the another. Okay, so these two, all these norms are equivalent norm. By equivalent norm I mean, you know two norms are said to be equivalent. Let's say this is some norm, let's say n, this is some norm. It is said to be equivalent to, let's say, oh, this is another norm, if there exists some c1 and c2 via which I can do this. Maybe I should write like this norm, say n, and n norm, I don't know, just some notation. Okay, these two norms are equivalent if there exists c1 and c2 positive, such that such that you know c1 times n is less than equal to this, and this happens for all x in Rn. Is the definition clear? Equivalent norm. Basically, once you have one norm, you can compute information about the another norm. So via this inequalities, I can say all these three norms are equivalent. Correct? So now let us move to the matrix norm. So a matrix norm, basically it is a norm function on the space of matrices. Scalar is a 1 cross 1 matrix, right? And Rn is a column vector. You can think of Rn as n cross 1 vector or 1 cross n vector. Now we want a norm on the whole metric space. So again, the definition of norm for matrix is similar, is actually same. That these four properties must satisfy: that the norm should be greater than equal to 0, norm of matrix A should be 0 if and only if A is 0. Then the third is that you can push alpha common as mod alpha, and fourth is the triangle inequality. Is it clear? Same definition we are working on. Okay, do you have any confusion? Okay, now let us see some example. You see, any matrix must be of this form, correct? Any n cross n matrix is of the form a11 and so on, aij's, right? N cross n matrix. Yes, yes. Hmm. Again, yeah, that could be confusing, I get that. See, norm, first of all, it's a function, right? As I told in the beginning, norm is a function. So we want, now we have a norm. When we say there is a norm on Rn, what do we mean? That there is a function whose domain is Rn that satisfies four properties, correct? Now we want another, some sort of function on the matrix space, that is MNR. MNR is the space of n cross n real matrices. So we want some function which we are calling matrix norm, that satisfy these four properties. Okay, so to explain, so now I am giving you some examples, and it is not difficult. Okay, let me just say this. Whenever you have MNR, what does it mean? That you have A11, A12, A1n. Am I correct? But don't be afraid, because this is again some Rn square element. You can write it like this, right? A to 1. When the first row finishes, you start with second row, you keep on doing this. So now this is an element in Rn square. Am I correct? So you can define norm. Am I correct? You can define a norm on this. For example, you can define the maximum norm. Mod Aij. Maximum will be the maximum of each of these modulus, right? This is infinity norm. Or you can define L1 norm also. What will be L1 norm? Summation mod Aij. Correct? And another norm is L2 norm. What will it be? Mod Aij square, then square root. Am I correct? So all these norms you have already studied. So don't be afraid when I am saying matrix norm. So these things are just representations. But why matrix norms are interesting? Because we can define one norm which is different from all others. Okay. So let us start with some examples. As I discussed, you can have these three examples. First is the L2 norm, correct? First is a copy of L2 norm. Am I correct? Second is the copy of infinity norm. And third is the copy of L1 norm. Now, if I give you this matrix, please compute all the three norms. Can you see this matrix? Take your time and compute the three norms, all the three norms. Root 5, root 5 is not correct. It should be root 3, right? Root 3, 1 and 3. Am I correct? This will be the norm. Now there is, so these are easy norms on the matrix and they are of interest in itself, but there is another norm which we will study now. This is called matrix norm subordinate to a vector norm. Okay. Yeah. Maybe I should put something. Yeah. Okay. Let us. So have you studied this in your numerical lectures? Matrix norm subordinate to a vector norm. Oh, you have studied, huh? Okay. Okay. So what is this? If I ask you to compute, let me just. Okay. So all of you have studied this. So I ask you one question, okay? You tell me the answer. Can you compute matrix norm subordinate to the maximum norm? How do you define matrix norm subordinate to a vector norm? What do you do? First, you take some matrix. Am I correct? Now matrix is a function on, you can think of matrix as a function on Rn to Rn. Am I correct? Where x goes to Ax. This is correct? Yeah. Now what happens, you see, so Rn you fix with some norm first. Let us say I am fixing it with some norm. This is a fixed norm now. This is a some fixed norm. It could be L1 norm, it could be L2 norm, it could be L infinity norm. So x belongs to Rn, am I correct? If I start with x belongs to Rn, then I can talk of this norm. Yes or no? Yes or no? Now, what about if I take Ax? Ax also belongs to Rn because A is an n cross n matrix and x is an n cross 1 vector. So the resultant will be n cross 1 vector, which is an element in Rn. Am I correct? So this way norm Ax is also well defined. Now what do you do to define a norm on A? You know, you take the ratio of these two, norm Ax by norm x, and because x is in the denominator, so you have to choose x to be non-zero. Then this is your matrix norm subordinate to a vector norm. Okay, this is what you have studied. Now my first question to you is, why does this exist? See, there is this maximum, right? There is this maximum written. My question to you will be, why does this maximum exist? One can only take maximum if it exists, right? Can you take the maximum of real numbers? You can take maximum of real numbers. I am not saying supremum, I am saying maximum. No, you tell me what is the maximum of real numbers. Do you know the difference between maximum and supremum? Do you know the difference between maximum and supremum? See, supremum and maximum both are the largest. See, if you are given a set, supremum and maximum both will be the, or both will be some numbers that are already larger than the elements in the set. All of you agree? But the property, the difference is supremum may not belong to the set, but maximum should always belong to the set. This is the difference. For example, if I give you 1, 2, 3, 4, this set 1, comma 2, comma 3, comma 4, what is the maximum? What is the supremum? 4. Okay. Now if I give you this interval 0, comma 1, what is the supremum? Supremum is 1. Am I correct? This is an open interval 0, comma 1. Supremum will be 1, but maximum does not exist. No, maximum is something that is attained. No, maximum does not exist. Maximum means some number in the set itself which is bigger than all other numbers. Yes, but maximum means no, no, it does not exist. Maximum is some member in the set, some member in the set that is largest. Okay. in the set. You take 0 is here, 1 is here. You claim maximum exists, so it will be somewhere in between, right? Let's say this is maximum. But all these numbers are greater than this. Then you might say, okay, this is not maximum, but this number is maximum. Again, you can find so many numbers. Yes. What about this? Now, what is the maximum here? 1. Now 1 belongs to the set. Okay. Supremum is also 1. When maximum exists, always supremum will exist. There is no chance. What about the this number? What about maximum? Supremum? Yes, supremum does not exist. In the sense it is infinity. Okay. So yeah, why did we start this? Yeah. So whenever in analysis we write maximum, so the question should be, why does this maximum exist? Am I correct? So this is an exercise for you to figure out. Please write down this question. Something is in a definition that does not mean for you it is working. You're a math student. You should question everything. So please write down this question. Why does this maximum exist? Okay. Now let us do some question. Just a minute. So I am giving you one matrix. Let's say 10, 2, 1, 6, 4, 9, 4, 1, 5. Then please tell me. So this is the matrix norm subordinate to infinity norm. Okay. Can you find this? How did you do that? So it turns out that the infinity norm subordinated to the infinity norm is nothing but absolute maximum of absolute row sum. Am I correct? That is maximum of modulus aij, j going from 1 to n, and this I varying from 1 to n. Now, what is this? This is the absolute row sum. So this will be 20. Now, who said 20? Ajay. Ajay, can you prove this? Prove this that norm, this L infinity norm will actually be equal to the maximum of the absolute row sum. Have you seen a proof of it? Okay. What about the matrix norm subordinate to L1 norm? Same matrix. Yeah. So tell me 19. It comes from the second column, right? And what about the L2 norm? Yes, L2 norm is maximum of lambda is I going from 1 to n, and you take the square root of this. Am I correct? Where this lambda is our eigenvalues of A transpose A. Yeah. So please compute it now. Or maybe I change this matrix for you people, so that like this will be easy. So you compute L2 norm for this matrix. 1 1 0, 2 5 minus 2, 0 minus 1. Or okay, let me make it more simple. 1 1 0 1 0 0 0 0 5. Yeah. Please compute it. All of you know what to do. Biswajyoti, Ajay, Atul. Okay. Is it 5? All of you? This was easy, right? So do you have to compute the whole way, or did you adopt some shorter way? Okay. Okay. So do you know, have you done this eigenvalue thing in normal matrices? So for example, here you could see A transpose is A, right? First thing first. So A transpose A will be A square. Am I correct? Now, do you know that eigenvalue of, you know, this collection sigma of A transpose A? It is the collection of eigenvalues of A transpose A. Okay? The collection of eigenvalues of A transpose A. Okay? This is called spectrum. What does it called? Spectrum. So because sigma A transpose A is A, so the eigenvalues of A transpose A will be same as eigenvalue of A square. Am I correct? Because A transpose A is A square. Now, do you know that eigenvalue of A square is nothing but lambda square, such that lambda is an eigenvalue of A? All of us know this. Why? Yes. Okay. Why does this happen? Okay, you just check whether this is true or not. If not, then tell me next time. This is another question. Okay. If lambda is an eigenvalue of A, I should not state this like this. If lambda is an eigenvalue of A, is lambda square an eigenvalue of A square? If and only if lambda square is an eigenvalue of. Here it happens at least because A is A transpose. So it is a self-adjoint matrix. So for self-adjoint matrix, this is true. Do you know all this theory, or like is it going above your head? Have you heard of normal matrices? Okay, then I should not confuse you with this. I should not confuse you with this, because I don't want you to be confused. Yeah. So today we have learned about this uh, metric subordinate norm. So as a vector in, as in, you know, as I told you, these matrices can be thought of as an element in Rn square, correct? And in Rn square you have three different norms: L1 norm, L2 norm, and L infinity norm. But in matrix norm there is an another notion of norm which is called matrix norm subordinate to a particular vector norm. And that is where the matrix theory differs from the scalars theory or the vector theory. So there are some interesting properties which you can observe, that norm of Ax is less than equal to norm A times norm X. All these kind of things you must have seen in your class. uh, can you tell me what will be the matrix subordinate norm of identity matrix quickly? This is the definition, right? What will be the norm of identity? If I is an identity matrix, then what will be the matrix norm of I subordinate to a given vector norm? Definition is given on the screen. You just tell me what happens when A is identity. Am I audible? One, right? Does it depend on the subordinated norm? See, when you're writing this norm, it depends on one thing, right? What norm here is taken? What is the kind of norm that is taken here, right? It it could be, it could be L2 norm, it could be L1 norm, right? Or it could be L infinity norm. But what I'm trying to tell you, when you take identity, it does not depend whatever norm you are choosing. Whatever norm you're choosing, the answer will be same. You see, because ix will be just norm x, right? And then it does not matter, it will always be one. So the norm of identity is one in any matrix norm. In any matrix norm, the norm of identity will be one. Is that clear? No. How will you define identity vector? Hmm. Any vector, it is one. Exactly. The norm against any vector, it is one. It does not depend on your choice of vector norm. That is what I'm trying to say. How about zero? What about the zero vector, zero matrix? Zero against any vector norm. Am I correct? Yes. Yes. So there are certain things that does not change whatever vector norm you choose. Okay. So okay, then we finish here. If you have some doubt, please ask. Yeah, sure. Mm-hmm. Okay, I'll tell you. This is okay. This is not a trivial question. Of course, this is a confusion that happens. Matrix and vector. So matrix we define any like m cross n in the sense m cross n, any arrangement of this form where m is the number of rows and n is the number of column. Okay, whereas vector is a column matrix. Okay, it is of this form m cross 1, so it has only one column. So vector is a column matrix. Okay, but matrix need not be a vector. Vector is always a matrix. Okay, matrix need not be a vector. For example, 2031, this is not a vector, this is a matrix. Okay, is that clear? More than one column, yes. And this is a column matrix. How many rows? M. So we say this is a vector in Rm. Vector in Rm. Why do we call it a vector in Rm? Because there are m choices, now x1, x2, up to xm. So there are m components. So hence this is in Rm. Is that clear? Yeah. Yes, scalars are just, it is just one cross one matrix. What is scalar? Some alpha. So you can write it as like one cross one matrix. Am I correct? Yeah. So scalar is basically a vector in R, something of that sort. But you should not call it as. I am not talking from a physics point of view. Okay, in physics, scalars and vector have different notion. They are two different notions. But when we are dealing with vector space, vector space, right? All of you know vector space? Oh, okay. So vector space, okay, then I will not go into this. But yeah, okay. Basic difference between vector and matrix is this. Vector is a column matrix, whereas matrix can be of any size. So hence any vector is a matrix, but not the other way. Okay? Yeah. Any more doubt? You can ask, please. Otherwise, maybe we can finish. We can end this meet. See, assignment questions you have to do. This is one thing that I cannot help you. You learn the course, and assignment question you have to do. Here we do similar kind of questions, and we learn some conceptual things. But then this is a course how the way it is designed. It is designed. Okay, I am a TA. You can always ask your doubt, and we try to do some concepts 1 hour, and today we did 1 hour question session. So it goes hand in hand. But if you expect me to solve assignment question, then I won't do it. No, 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 no. That is not allowed. Please, that is strictly prohibited. Basically, because assignment submission has also some marks, right? You can maybe discuss among yourself. Why don't you do it? You three people are here. You have enrolled in this course, right? Ajay, are you also there? Biswajyoti, are you also there? Maybe you can share your details with each other and discuss among yourself from a WhatsApp group. All these things are appreciated. Why don't you do it? Hmm. But that, see, the thing is, in the lectures, certain proofs are not, the lectures are numerical based, but see, what am I doing? I have specific instructions from the instructor. Okay. So this is how it is supposed to be running. But of course, I get your point. Maybe I'll try to bridge that gap, but it comes very naturally because session happens and then we have the 1 week is finished and then we have the tutorial session. Do you get my point? So I don't know if you're getting my point or not. For example, okay, in short, I will try to bridge that gap. Is that fine? But good idea would be you three exchange your details or something and then communicate among yourself. This is always a better idea. You want to learn, then grow together, learn together. Okay, then see you next time.